Good morning. In this video, we're going to be talking about solving practical problems or word problems using rational numbers. This means that we're going to be solving problems that use both decimal numbers and fractions. And the following steps aren't necessary for each problem, but we're going to be using a combination of some of them in each problem. And you'll see what I mean in a bit. Of course, in the end, we'll have to solve. These are just ways to make solving easier. So, for example, if we are intimidated by fractions, like complicated fractions or large numbers that also have decimal points, then we can substitute those numbers for simpler numbers to see how this problem can be solved and then put back the original numbers. So that's one of my favorite strategies of solving problems. The second one is, and this actually should be done for every word problem, is highlighting in some way or underlining any key words. And this means basically finding out what the necessary information is, so that we're not distracted by other information. And then number three, once we do that, or before we start solving, we need to find out which operation should we use. Is this an addition problem, or should we be adding in this situation, dividing, multiplying, subtracting, whatever? And then if you want to, you can always visualize the problem in a picture or diagram. And that's one of the things we did when we wrote word problems, and we're going to be revisiting this again and again, because it's a very good way to understand what's going on. Okay, so let's start. We're just going to go through 5 questions and follow these steps to solve them. Question number 1. A calculator is 8.9 centimeters long. How far will 130 calculators reach if laid end to end? Give your answer in meters. Okay, so this is simple. If we look back here, it says use simpler numbers to avoid confusion. So if you would like, instead of this 8.9, for now, we can say 8. Okay, so just to simplify it, we're gonna put it back in when we're done. But for now, let's just do that. Okay, and then let's see. Highlight and underline keywords. So a calculator is 8.9 centimeters long. How far will 130 calculators reach if laid end to end? So we're laying them end to end, meaning right next to each other, one after the other, right? Give your answer in meters. So saying give our answer in meters, but our measurement here is in centimeters. So we have to remember that. And then it says determine which operations to use. Okay, so if I'm laying calculators end to end, and I'm using 130 calculators, I need to find the length of them. So in this case, I think multiplication would be a good operation to use. And then draw a picture or diagram. Of course, this could be pretty simple. We could just do boxes like this, since we don't care exactly what it looks like, and put some dots here. So then in the end, we're trying to find this whole length. Let's make this a last calculator. All right, so it seems pretty straightforward. Let me start solving in blue here. If the length was 8, then I would really just say this is 8, 8, 8, so 8 plus 8 plus 8, or 8 times, essentially it would be 8 times 130, right? But so we know exactly what to do. We know that it's multiplication. We know that we're going to multiply by the number of calculators, which is 130. But we know the real length is 8.9. So let's do that now. So let's actually solve this problem. So 130 times 8.9. So the way we multiply, like we know, like we've practiced many, many times, is we ignore the decimal point completely. I'm not going to erase it here. Let's erase it. So it's as if we're doing 130 times 89. But we know that in the end, we have one decimal place. The 9, right? One decimal place. So we need to put that back in the end. a note here, okay? So let me multiply. Okay, so our final answer is 11,570. But wait, right? I have to put in my decimal point, and that's just one place here. So we got a final answer of 1,157.0, but I don't have to write the 0.0. In fact, if I do have a 0.0, I need to simplify it and not write it at all. But this was in centimeters. This 8.9 was in centimeters. So my answer is still in centimeters. Now it says give your answer in meters. And we know that in every meter, we have 100 centimeters, right? So if we want to turn this into meters, we need to divide by 100. So it's going to be 1,157 divided by 100. And if you know anything about dividing by multiples of 10, we just move, if we have a decimal place here, we just move it to the left twice because we have 2 zeros. So our final answer would be 11.57 meters. Good. So we used the strategies we discussed here. We simplified the numbers first. We highlighted and underlined keywords. We determined which operations. We even drew a picture. And then we started solving. Then we can say 130 calculators will go 11.57 meters far. All right. Number 3 says, Jenny takes out a loan of 2,200. She pays back 42.6 each month and doesn't have to pay interest. Okay, so the loan is 2,200. She pays back 42.6 each month. If she has made 5 repayments so far, how much does Jenny still owe? All right. So we have an initial loan, right? This is the loan. And every month she's paying out an amount. So every month it's coming out. It's coming out of that, right? So I can see that this is subtraction since we're taking money out. Now, if I simplify these numbers, let's say I'll keep the 2,200, but let's make this 50 just to see what it would be like. It would be 2,200 minus 50. That would be like what's left after 1 month, right? And so this 50 needs to be multiplied by the number of months, which I'm just going to call m. So if it's 2 months, then it'd be 50 times 2, so it's 100, and then we subtract. If she has made 5 repayments so far, so instead of m here, we know that she already made 5 repayments. So far, it should look like this: 2,200 minus 50 times 5. Okay, I think we're ready. I think we're ready to substitute in the real numbers. Let's not forget about that. So the real expression would be this: 2,200 minus 42.6 times 5. And we know it's subtraction because we're taking money out of the loan. The loan is 2,200, and we're slowly taking money out to see how much she still owes by the end. All right, so let's start. If we're simplifying an expression like this, we need to follow the order of operations, which a lot of you already know is PEMDAS. Let's write it like this. We start with parentheses, then exponents, then multiplication and division can go together, and then finally addition and subtraction as well can go together. So in this case, I see multiplication and I see subtraction. So let's start with multiplication first. We have, and let me do it on the side here, we have negative 42.5 times 5. Okay? We know our answer is going to be negative because they have different signs. and then we ignore the decimal point, we multiply. So our answer is negative 212.5. And I put the decimal point here because we had one decimal place here. Okay, so negative 212.5 is what we have. This is after 5 months. So just so we can label it, this is money paid back after 5 months. So money paid back after 5 months. All right. So this became this 2200 minus 212.5. Now, how can we subtract? If you don't remember, we place the numbers on top of each other with the bigger number on top. So 2200 on top, 212.5 on the bottom. The decimal places need to line up. So here we need to add a 0.0. So you have 1,987.5. This is in dollars. Our answer is in dollars. It looks like it makes sense. It's a reasonable answer. So our final answer is, again, dollar sign first, $1,987.5. This is how much Jenny still owes. In terms of our solution, I haven't been writing out the full sentence, but in this case, we would say that Jenny still owes $1,987.5, right?